Assalamu alaikum everyone. Today I will be talking about gas chromatography. The basic components of the gas chromatography are carrier gas system, sample injection system, the column, detection system, and the recorder. Carrier gas system must be inert, easy to handle, easily available, cheap. The helium is the most commonly mobile phase gas used, although argon, nitrogen, and the hydrogen are also used. These gases are available in the pressurized tank. Pressurized regulator gauge and the flow meter are required to control the flow rate of the gas. So as the gas is the mobile phase and when it is present in the pressurized tank, so to control the pressure of the gas, the regulator gauge are used and the flow meter is present to control the flow rate. Carrier gas system often contain molecular sieve to remove the impurities. Sieve is to remove the impurities and water from the mobile phase. It is assumed that the flow rate, example 1 ml per minute, will be constant if inlet pressure remain constant. Inlet pressure 10 to 50 psi above room temperature, which lead to flow rate of 25 to 150 ml per minute with packed column and 1 to 2 ml per minute for the open tubular columns. Psi means pound per inch square or the pound per inch squares. Sample injection system. To achieve the high column efficiency, the sample must be of the suitable size. Slow injection or the oversized sample cause band splintering and the poor resolution. Calibrated micro syringes are used to inject liquid sample through a rubber or the silicone diaphragm or septum into a heated sample port located at the head of the column. The septum purge outlet prevent the septum bleeding components from the entering the column. You can see in the diagram that this is the rubber septum on which the micro syringe is inserted and the sample is inserted into the heated metal block. This is the heated metal block. Okay, and here is the column. You can see the sample purge is there, outlet, sample outlet, so that it prevent the bleeding of the septum entering into the column. Okay. The injection method in the gas chromatography, either it is a split. Split is a routine means of introducing sample volume in the open tubular column. Other is the splitless, best for the trace levels of the high boiling solutes in the low boiling solvents, and the other is directly into the column, best for thermally unstable solute and high boiling solvents because the injection system are heated. So the solutes which are thermally unstable, they are directly injected into the column. Okay, what happened inside the column? You can see over here it is injected and over here is the detector. The most interaction with the stationary phase, and this is the least interaction. So we can see the mixture is installed and the sample is being separated over here, which is exiting the column. This component is least interacted with the stationary phase, and this over here is the most interacted with the stationary phase, and it is it exiting the column at the end. In this slide we will see how the sample is injected and it cross the column and go into the detector. We will see the different colors. You can see first blue, purple, and slowly the green, on the basis of which different peaks are formed with the time. You can see the different peaks are available. First the blue exited, the blue peak is there, then the purple exited, the purple peak, and the last one the green peak with the change in time. The different peaks are available as they are exiting the column. The column are of various type depending upon the material. Stainless steel, copper, glass, or the plastic. May be coiled in the V or the W shaped. Must be inert, good thermal properties, non-fragile, easy to coil. Two types of the column are used in the GC: packed column and the capillary column or adsorption column. Okay, the first type, that is packed column, made up of the different, can be of the glass or the stainless steel tube filled with the dry and the earth solid support such as diatomaceous earth. So it is packed with the diatomaceous earth, which is type of the silica but is of the fine quality. Liquid stationary phase is coated on the solid support. So if the stationary phase is liquid, it is coated on the solid support. If the stationary phase is solid, then it is the solid diatomaceous earth. It have more sample capacity than the capillary column. Solid support would consist of the small uniform spherical particle with good mechanical strength and the specific structure area. Material should be inert at elevated temperature and readily wetted with the liquid phase to give the uniform coating. This is the diagrammatic view how this is packed column and this is open tubular column. Open tubular column can be of two types: wall coated open tubular column and the support coated open tubular column. You can see how stainless steel or the copper column is coiled in the circular way. Advantages of the capillary column is shorter analysis time, higher resolution, increased sensitivity, and the lower sample capacity. GC detectors monitor the GC column effluent, that is eluated component, and the variation in its composition must be adequate, sensitive, having the good stability and the reproducibility, a short response time that is independent of flow rate, and it should be easy to use. Okay, different detectors can be used in the GC: flame ionization detector, electron capture detector, thermal conductivity detector, and the nitrogen phosphorus detector. So in the next lecture we will be discussing each detectors one by one. So in the chromatography, the data produced by the chromatography is called as the chromatogram. So the result which we will see on our recorder is the chromatogram with the different peaks. Each peak represents a compound in the original sample. The retention time indicates the identity of the substance. So this time will show the identity of the substance. The integrated area represents the amount of the substance in the sample. Thank you.